In problem 1, we are given the beam with the loading shown. It's a long beam with a force at the end and a torsional force acting on the end of the beam as well. We are asked to identify the stresses at the stress elements A and B, and then record the direction of all these stresses in the provided table. To do this, we first use this stress tensor on the problem. And the mistake that I made on this problem was not writing this stress cube on my equation sheet, and therefore I got confused on how to approach some of the stresses. When you look at the stresses at A, there are no axial, there are no pure shear. As you can see, there's no force acting right along either of these forces. So both the axial, the shear for A are going to be 0. The axial and shear for B will also be 0, as there are no forces acting in that area. The bending normal at point A will be positive x, and this is because of the force that is getting applied at the very end of the beam downward. You can also relate to this stress cube there to get your reference. The stress element B will not have any bending normal, as it is on the side of the beam and therefore has no reaction. There will be no transverse shear for force A, as there is no force acting in this y direction. However, on stress element B, there will be transverse shear at the negative x and y location. We can look at the stress cube that I mentioned earlier right here, so that you can see the x and y shears. The very last step, it gives us the torsional shear for B, and then we have to solve for the torsional shear for A. When I solved this on the test, I actually flipped the sign for the torsional shear and assumed that it was negative. That was a mistake, like I mentioned before, because I didn't have this stress cube, and I mixed up my right-hand rule. In problem 2b of this test, we're tasked with getting an accurate estimate of this ductile materials yield factor of safety given the stress element above. My error when solving this problem was not seeing this phrase right here that says accurate estimate, and all I read was ductile, and therefore on my equation sheet I used the ductile failure theory to solve this, which gave me an answer that was close, and I did get the part will not fail, but I didn't get the correct sigma prime value. To solve this problem, it's pretty simple. You use the flow chart on the equation sheet that you gave us to solve that it's not going to be conservative, because we want an accurate estimate, and then from there it points us right at the distortion energy failure theory. After we do this, all you have to do is plug in the values from this stress tensor and plug into this equation here, and once you do all that, it gives you a value of 78.1 megapascals, and then you plug it into the other half of the equation and resolve for the factor of safety, for the yield factor of safety, and that will give us a value of 2.82 as our value, and that will tell us that the part will not fail because it's greater than 1.